going to do a couple different things with proportion. One is determining, is it a proportional relationship or is it not? And then solving for unknowns in a proportion. We'll be doing kind of combinations of both of those. Remember that a proportion are two equivalent ratios. So we just have to determine, are the two ratios equivalent? Now let's look at a couple different examples. Here's our first one. We'll do 2/3 and 8/12. We have to determine, are those proportional? For some reason my pencil's not showing up. 3/12. 2/3. Now there are two ways that we're going to do this. One way is to multiply this direction. Oh, let me change, instead of 3, let's make that an 8. That'll make this a better example. Change that to an 8. So it's 2/3 and 8/12. The first way we're going to do this is to just look straight across. So if I do 2 times 4, that'll give me 8. What that means is that if I also multiply 3 times 4, it should give me 12. Does it? Yes. So the answer is yes, it is proportional. Sometimes that's going to be really difficult because we're going to have fractions or like really, really large numbers or really, really small numbers. And the decimals and things like that, it's going to be really hard to see these multiplications. There's another way that we can solve this by cross products. 3 times 8, 3 times 8 gives us 24. And this cross product, 2 times 12, also gives us 24. When your cross products are equivalent, then your fractions are proportional. So yes, we have confirmed this in two separate ways. Okay. So we have confirmed that those are proportional in two separate ways. Let's look at another example. If I have, let's say, 4/2 and 16/5. Are those proportional? Anybody think they got it? Stuart? No. Yeah, I just look straight across here. 4 times 4 gives me 16. 4 times 2 gives me 8. Is that 8? So it's not. You could also double check that. If you do cross products, 2 times 16 gives me 32, and 4 times 5 gives me 20. So I know that those are not equivalent. What if you had some decimals in there? What if we had 3.4 to 1.6, 5.1 to 2.4? Are those ratios proportional? Are they proportional? Anybody find it? Joe?
Yeah,
And how do you know?
I cross multiplied and it will equal.
So you cross multiplied 8.16? Did anybody not cross multiply and do it the other way? Is that what was your scale factor there? What did you multiply by to get to that?
I just multiplied them both by 10.
You multiplied them both by what?
I don't know.
Okay. Did anybody find what that factor was? What do you multiply one by to get to the other? If I take my first number here, 5.1, and divide it by that number there, and I divide it by that number there, I'm going to get the factor that it's going by, which is 1.5. So if I do 3.4 times 1.5, it gives me 5.1, which means if I do 1.6 times 1.5, it'll give me 2.4, and it does. Let's try another one. Oh, that's supposed to say number of guests. Sorry. I am. So the number of guests and the number of cookies. So when there's 2 guests, there's going to be 4 cookies. When there's 4 guests, there's going to be 8 cookies. 6 guests, 12. Are those set of numbers proportional? Are they proportional?
Yes.
Why? Okay. So you're saying that there is 2 cookies for every 1 guest? Is that what you're saying? What did she just find? We got a definition for what she just found.
Ratio?
It is a ratio, yes. That's a ratio of guests to cookies or cookies to guests. But she found it for 1 guest, there are 2 cookies. There's a certain type of ratio that is. Kevin? Yeah, what it is it's our unit rate. So for every person, there are 2 cookies. That's our unit of measure. So for every 1 guest, there's 2 cookies. And it never changes. It's always that 1 guest, 2 cookies. Does that rule stay? So what that means is that every single one of these fractions is equivalent to this one right here. Is that true? Yes, that's true, and yes, it's proportional. And you're saying, well, wait a minute, we solved that one differently than the other one. We really didn't. Every proportion is an equivalent fraction. If you wanted to, you could do this the same way. Times 2 gives us 4. Times 2 gives us 8. 2 times 3 gives you 6. 4 times 3 gives you 12. It doesn't change. That idea stays the same. 2 times 4 gives you 8. 4 times 4 gives you 16. So all of those proportionally are the same. You can also multiply diagonally. 4 times 4 gives me 16. 8 times 2 gives me 16. All of those are proportionally equivalent to each other. We've looked at that in several different ways to prove that it's true. Let's try another one. How about the number of socks and cost? So 1 pair of socks are $2. 2 pairs, $4. 3 pairs, $6. 4 pair are $6. Is that set of numbers proportional? Natalia, why? I see. Excellent, very good. Yeah, the unit rate doesn't apply to all of those proportions. So if you've got 1/2, so for every 1 pair of socks you get, they're $2. That means that if I buy 4, it should be 8, but it's not. So this is not a proportion. Excellent. The next thing we're going to need to do is solve. You probably remember doing this last year. So solving for proportions. We're going to use some of the same skills that we used up there at the top in order to solve for these unknown variables. One way is to figure out that factor. So this is my unknown. I need to figure out what that number is. So if I do 36, I need to go in the other direction. What do I need to do to 36 in order to get 6? That?
Divided by 6.
So if I divide that by 6, it'll give me that 6. That means because this is a proportion, if I do 24 divided by 6, it'll give me that unknown. So what is the value of that? 4. Very good. There is a second way to solve this. The second way to solve this, the more efficient way to solve this, is to multiply diagonally and then divide by your leftover number. So what I'm going to do is 6 times 24 gives me 144. Then I'm going to divide it by my known number, divide it by 36, and that'll give me my unknown. Essentially what it's doing is cross-multiply. But since you don't know what this is, you know that the result of this is going to be the same as this. So if you multiply diagonally and divide by this, it'll leave you with whatever that is, which was 4. What if you have 7 over 5 and 10.5 over x? Solve for that unknown. Anybody find it? Tommy, what'd you get? That's what I got too. Multiply diagonally, divide by 7, and it'll give you 7.5. Five times 10.5 gives you 52.5. Divide it by your leftover number, which is your 7, and it gives you your solution, 7.5. Let's increase the difficulty a little bit. So let's say that Ryan started a new job. And we're all excited for him. He started it. We don't know how long he's going to last.
Not that long.
He works 15 hours a week. All right, so Ryan started a new job working 15 hours a week. After how many weeks will he have worked a total of 75 hours? You're going to start by setting up a ratio. The first thing you're going to do is set up a ratio. I know that he works 15 hours in 1 week. You need to figure out how many weeks will it have been for him to work 75. Alexis?
5 weeks.
5 weeks. And how did you get that?
I did 75 times 1. I didn't know do that. I already knew the answer. I did 75 divided by 15, and I got 5. It's not bad.
Sure. All you have to do, if you set up the proportion, you multiply diagonally and divide. 75 times 1 obviously gives you 75, and then just divide that. So you know it's 75 hours total divided by 15 hours a week, leaves you with that 5 weeks, that 5-week period of time. All right, so there's your next one. On a cross-country road trip, a family drives 240 miles each day. Write and solve an equation to determine how far the family travels after 4 days. What is your first ratio going to be? Ryan?
240 miles and over one day.
So 240 miles in 1 day. That is our unit rate. That's how much we're traveling in 1 day. What's our other ratio going to be? So x over 4, because we want to know the number of miles in 4 days. So what do we get? Aiden?
560 miles.
960 miles. Perfect. Multiply diagonally, divide by your leftover number. Excellent.